Did you know that you can use artificial intelligence to generate professional-looking headshots? You only need a handful of images to make it work. Hi, I'm Jen. If you're new here, Stability AI has now made Stable Diffusion, an AI text-to-image generator available for everyone to use. In our previous episode, I've demonstrated how to install, configure, and use Stable Diffusion to make fantastic images. In this video, I'll show you how to use the textual inversion technique to train the AI model on your images. To train textual inversion, you'll need to have a modern consumer-grade graphics card with at least 8 GB of video RAM. In my case, I have an NVidia Tesla M40 with 24 GB of VRAM with a 3D printed cooling fan kit that was purchased secondhand from eBay for about $180 total. It's my understanding that this works best with at least 16 GB of VRAM. It's possible for it to work on 8 GB. The method for low VRAM will be covered in this video. Start up Stable Diffusion and let's get going. Section 1. Creating an embedding. Click on the Train tab and let's create an embedding. I'm giving it the name Doebelin. This will be the name of the PT file that is generated and in your logs. The initialization text is required and must be unique. The star is not required. My initialization text is Doebelin, which is unique. Then click the Create Embedding button. This creates an embeddings folder in the Stable Diffusion root directory and saves the initial blank training file to it if one does not already exist. Section 2. Image Processing. Before beginning, I recommend a few steps to prepare. First, download and install Fast Image Resizer. This will help you resize images in bulk. I've provided a link to this free software in the description below. Second, create an easy-to-find image directory for you to start from. Mine is called Source and is located on the desktop. Right-click on any picture in the source directory and click Send to Image Resizer. Leave the Fast Image Resizer window open while you delete this image in the new Resize directory inside your source directory. Change the resolution to something bigger. I'm changing it to 1024 by 768. Now click back into your source directory and select all the images. Drag them into the Fast Image Resizer window and let go. Verify your resized images are at least 512 by 512, which these are, so we can move on to the next step. Switching into Stable Diffusion, select the Preprocess Images tab. Here, paste in the source directory from the previously resized images. Name a new folder for the destination. Leave the width and height settings to 512 by 512. Next, check the blip, which stands for Bootstrapping Language Image Pre-Training, to have the preprocessor automatically assign a caption file name. Click the Preprocess button to begin. This should only take a few moments. The command prompt shows that one textual inversion embedding has been loaded. This is the one that we created in the previous section. This resizes the images and adds captions to the file name. This is a great starting point, but checking the names for accuracy is imperative. When it finishes, visit the destination folder and check the captions for accuracy and conformity to the aspect ratio of 512 by 512. Section 3. Training. Switch into Stable Diffusion and click on the Train tab. Select the embedding that you created earlier. Leave Hypernetwork alone. I'm using a learning rate of 0.005. Next, paste in the location of your properly sized and captioned images into the dataset directory. Take note of the log directory. Visiting this directory, it contains folders with dates and the names of the embeddings created on that date. Within these folders are the partial training files and logged images that were created during training. The next thing on the list is the prompt template file. By default, style filewords.txt is used. Let's review the contents of this text file. Navigate to the Stable Diffusion folder and click Textual Inversion Templates folder. Open the style filewords.txt file. This has descriptions such as a dirty painting. This is not good for training faces. These are customizable. I've created 2 templates that contain more human-appropriate terms. I'll make these templates available in the description below. The syntax should follow: square brackets with name points to the embedding name. The square brackets with file words points to the caption of the source photo file names. An example is a photo of the handsome Doebelin, a man standing in front of a building, is how one of the generations will be presented during training textual inversion. Moving down the page, width and height should be set to 512 by 512. I've set my steps to 1,000. The image creation feature is helpful to gauge how well training is going. I'm setting mine to 10. It will create an image at every interval that you have set. This means it'll generate a preview photo every 10 steps. Please note, if you have 8 gigs of VRAM or less, try setting the image creation value to 0 to disable it. On a machine with 8 gigabytes of VRAM like my RTX 3070, it is possible to train, but then there's no free VRAM available to generate the image preview, and we get an out-of-memory error. Setting this value to 0 disables the preview and stops the interruption to training. This limitation can be overcome by using a different video card, such as the Tesla M40 that we're training with here. The last setting, save a copy of embedding to log directory, saves a partial training file at the step interval value that you've selected. Now click the Train Embedding button. If you see a message preparing the dataset, it is loading the captions, file names, and images into memory. Here we can see it work through the prompts we created from our templates file. The loss metric is a gauge of how well the training is going. The numbers should trend downwards as training progresses. High loss value would indicate that training is not going in the direction you want, and you may want to adjust the learning rate to a lower rate, use a different picture set, and/or adjust the number of training steps. This step might take a while. Okay, training is finished. Section 4. Checking your work. If you let the software complete all the steps, it'll move the PT files into the embeddings directory for you. Now go to the Text to Image tab and type in your token prompt and hit Generate. I saw some way better pictures during training earlier on. Let's go to the log directory and find out where things went wrong. Better, but not quite. These images around 600 seem to be okay. Navigate back to view the logged partial embeddings file from the Textual Inversion embeddings folder. Then open the stable-diffusion embeddings folder in a separate window and delete the PT file that we didn't like. I'm dragging the 600 series PT file over and renaming it to whatever I want to prompt with. Click to generate a new image. I like these better. That's it. I think we're done here. Let's recap our learning objectives. In this video, we learned about resizing images, proper captioning, creating embeddings, working with low VRAM, editing the prompt templates, and choosing the best PT file from the training set. In the next video, I'll be working with scripts under the Image to Image tab, like outpainting, and how to create the XY grids. If you have any questions or want to see me cover a specific area of Stable Diffusion, please comment below. Otherwise, thanks for watching.